a good strategy that you can use for converting concentration units, if you're converting within the same type, okay, then all you really have to do is assume any value for either the denominator or the numerator in your defining equation for the concentration. For example, let's say you knew the molarity. Okay, so what's the definition of molarity? It's moles per liter, right? Moles of solute per liters of solution. Okay, so let's say you knew the molarity, then you can assume either an amount for the number of moles or an amount for the volume in liters, and you can figure out the other. So if I know the molarity, and if I know one of these two, if I know mole solute, then I can figure out liters of solution. If I know liters of, if I assume the value of the liters of solution, and I know the molarity, and I can figure out the moles of solute. Okay? So you can assume any value for either the numerator or the denominator, and then use the defining equations to figure out the other one. And then all you have to do is convert these amounts to whatever amounts you need to do to figure out the concentration in whatever unit you want. Let's illustrate that with this. Vinegar is 5% weight by volume, acetic acid in water. This is acetic acid, CH3COOH. Let's calculate the molarity. Well, what's the defining equation for this? So we know the 5%, okay, weight by volume, okay. So that's one. What's another way of expressing 5% weight by volume? Now you say that is 5.0 grams CH3COOH, okay, per deciliter of solution, right? It's your concentration per deciliter of solution. So what did we say we were going to do? Assume that we know the numerator or the denominator, right? So this is equal to mass. In general, that's the mass of acetic acid over the deciliters of solution, correct? So what would be a good number to assume to make calculations simple? Assume a number like 1 or 100. Okay, so let's assume you have 1 deciliter or 100 mils. Okay, so let's assume we have 1 deciliter of solution. So that's the volume of the solution. Okay, so the volume of solution. How many grams of solute do you have? 5, right? So then the amount of solute is 5 grams, CH3COOH. Okay, so we say, in other words, what we're saying is percent weight by volume is equal to mass over volume, right? Mass of solute over volume of solution in deciliters. Okay, so we know this. We assume we have 1 deciliter of solution. We figure out what the mass would be, 5 grams. So given this, I can figure out molarity, right? How do I figure out molarity? What's the definition for molarity? Molarity is mole solute over liters of solution, correct? What's my solute here? Acetic acid, right? So how do I convert 5 grams to moles? Grams to moles, what do? You use the molar mass, you divide by the molar mass. So times 1 mole over molar mass of acetic acid is 60.06 grams per mole. So that cancels out grams. So I just changed my moles of solute to my grams of solute to moles of solute. And what's the volume of my solution? 1 deciliter, right? Which is the same thing as what? 100 mils, right? So this is 100 mils. But what should I do with my 100? I have to 100 mils. I have to change that to liters, right? So I'll change that to liters. So 1 liter is how many mils? 1,000 mils. So that gives you your molarity. So what's your molarity then? 5 over 60.06 divided by 0.1. Okay? What would that be? Let's see. Calculator. You have 5 divided by 60.06 divided by 0.1. Okay, 100 over 1,000 is 0.1. So this is 0.833, 0.83 moles per liter. Okay, why am I only keeping 2 sig figs? I only have 5.0 here. Okay, 2 sig figs. So my answer should have only 2 sig figs. How about if we went the other way? What's the define? So you know your molarity. What's the defining equation for molarity? Molarity is mole solute over liters of solution, right? Okay. So what do you want to assume? You want to assume moles or liters? It doesn't really matter, whatever amount you want, because all of these things are proportional. By the way, back here, if I assumed I had 2 liters of solution instead of 1, then I would have figured that I'm going to have 10 grams of acetic acid, right, instead of 5. And then what I'll have when I do my molarity is I'm going to have 10 over here instead of 5, but then I'll have 200 down here instead of 100. So I end up with twice as much in my numerator and twice as much in my denominator. I'm still going to get the same answer. The thing to realize about your concentrations is they're a ratio of 2 things. So it doesn't matter how much you assume for your numerator, your denominator will just follow suit. If you have twice as much in your numerator, your denominator is going to be twice as much. The ratio will still be the same. Okay. So here, let's assume then a good thing to do for molarity. I like to assume the value for the denominator. Makes it easier. You end up, and I like to assume it to be 1 or 1,000. Makes it easy to do the calculation. So assume you have 1 liter of solution. Okay. So if you have a liter of solution, what do you do? How many moles of sodium chloride would you have? 0.15. That's what molarity means, right? How many moles of solute you have in a liter of solution. So how do I calculate percent weight by volume? It's just grams of your solute, which is NaCl, right? Divided by volume in mils times 100%. Right? So how many grams do I have? Or you can say that's grams of sodium chloride per volume in deciliters, right? Volume in deciliters of your solution. So how would I do this? I change my moles, 0.15 moles NaCl. I change it to grams. How do I change that to grams? Molar mass of NaCl is how much? 58.44 grams NaCl per mole of NaCl. Okay, so that's my numerator. Divide that by my denominator is how many deciliters? 1 liter. How do I change a liter to a deciliter? You can say 1 liter is 10 to the negative, 1 deciliter. Sorry. You say 1 deciliter is equal to 10 to the negative 1 liter. Okay. So that's your conversion factor. 1 deciliter is equal to 0.1 liter. So liter cancels out. You have your unit becomes gram sodium chloride per deciliter of solution. So what would this number be? 0.15 times 58.44. It's 8.766 in the numerator, right? Is that correct? Divided by 1 over 0.1, that's 10 deciliter, right? 1 over 0.1 is 10. So you have 0.8766 grams per deciliter. What's another way of writing? How many sig figs should I be keeping there? I only have 2 sig figs, so this is going to be 0.88 grams of sodium chloride per deciliter. Okay? Or you can say it's 0.88 percent weight by volume. Okay? Another example. According to the American Association of Clinical Chemistry, glucose concentration collected in blood that's collected after an 8 to 10 hour fast is considered normal if it's within 70 to 99 milligrams per deciliter. A diabetic person will have a fasting blood glucose level higher than 125. So let's say you took a blood sample from a person after an 8 to 10 hour fast, and you found that the concentration of glucose in his blood is 8.0 millimolar. Milli means what? 10 to the negative 3, right? So 8.0 times 10 to the negative 3 moles per liter. Is this person diabetic or not? So all you have to do is convert this molarity to milligrams per deciliter and see if it falls within 70 and between 70 and 99, right? So let's change that. 8.0 times 10 to the negative 3, okay, moles of, what is it? Glucose per liter of solution. That's our molarity, right? So what do? Assume, I know my molarity, so what do? I assume one. Assume you have 1 liter of solution, right? Volume is 1 liter. How many deciliters would that be? Since I'm ultimately going to be interested in deciliters, right? So I just changed that to deciliters. 1 deciliter is 10 to the negative 1 liter. Deci means 10 to the negative 1. So our volume is 10 deciliters. So if I assume I have 1 liter, how many moles do I have? (8.0 times 10 to the negative 3 moles, right? Moles of glucose. So how many grams of glucose do I have then? I have to change my moles to grams, right? So how do I change my moles to grams? 8.0 times 10 to the negative 3 moles of glucose. What would that be? Okay, so molar mass of glucose is 180.2 grams, okay, per mole. 1 mole of glucose. Okay. So moles cancel out. So what's my percent by vol? What's my milligram per deciliter? Oh, I have to change this to milligrams, right? So I want milligrams. How do I change grams to milligrams? 1 milligram is equal to 10 to the negative 3 grams. Okay, milli means 10 to the negative third. Okay, so what would 5 milligrams of glucose be equal to? Let's calculate that. You can say that 8 times 10 to the negative third times 180.2 divided by 1 times 10 to the negative third equals 1441.6 milligrams. Okay? Or a quick way is, if you don't want to have to worry about that 10 to the negative 3, you can cancel that. Right? So, what was that? 1441.6? So 1441.6. Keeping in mind you only have 2 sig figs there. Okay. So what's the concentration? Milligrams per deciliter would be equal to 1441.6 milligrams in how many deciliters? We have 10 deciliters. And 10 deciliters is an exact number. We're assuming we have exactly a liter. Okay. So 10 deciliters. So that gives you, and keeping in mind you only have 2 sig figs, that gives you 140 milligrams per deciliter. So is this person diabetic or not? Diabetic, yeah. Okay? So here's a neater way of setting this all up. You can say milligrams per deciliter, okay, is equal to, you could have done it like this. What was it? 8.0 times 10 to the negative 3 moles of glucose, okay, times 180.2 grams glucose per mole of glucose, times 1 milligram is 10 to the negative 3 grams. So that's your numerator. That's milligrams, right? Moles glucose cancel out, grams glucose cancel out. That gives you milligrams in the numerator. And then in your denominator, you say you have 1 liter. Change it to deciliter. A deciliter is 10 to the negative 1 liter. So that's your numerator, and here's your numerator, and here's your denominator. Okay? So that's how you change your concentration units. Here's one. This one is converting units within type 2. So from mass percent or percent by weight, you want to calculate molality, parts per million, parts per billion, mole fraction of HCl, and mole fraction of water. So concentrated hydrochloric acid solution in the lab, you'll find it on the label. It says it's 37% by mass HCl. The rest of it is water. Okay? What would be the molality, the parts per million, parts per billion, and the mole fraction of hydrochloric acid, and how much the mole fraction of water? So percent by weight. So what would be a good number to assume there? Anytime you have percentages, you can assume 100 for the whatever the denominator is, right? So you assume in this case, and like I said, it doesn't matter what you really assume, because when you take these ratios, you end up with essentially the same number. So you have to assume in this case you have 100 grams of solution. Okay? So what would be the mass of the HCl? 37 grams. How would be the mass of the water? 63 grams. Okay. How do I calculate molality? What's the definition for molality? Remember, HCl is your solute, right? And your water is your solvent, right? So molality of HCl is moles of HCl, which is our solute, right? Divided by kilograms of water, which is our solvent. Okay, can we calculate moles of HCl? How do you change 37 grams to moles? 37.0 grams HCl. Change it to moles. 1 mole HCl is how many grams? H is 1.008. Chlorine is 35.45. So it's 36.46. So HCl is 36.46 grams per mole. Okay? So that gives you moles of HCl in the numerator. How many kilograms of water do you have? Right here, 63 grams. How to change that to kilograms? How do you go from grams to kilograms? You want 1 kilogram equals, kilo means 10 to the third, right? So 1,000. A kilogram is 1,000 grams. Okay, so that cancels grams. So our molality is equal to, how would that be? 37 divided by 36.46. Did I record? Yeah, I am recording. Okay, 36.46 equal, what did I just do? Okay, clear. Okay, it's 37 divided by 36.46. So that's 1.014 in the numerator. Okay, 1.0148, so 1.015. I'm keeping an extra digit there. I should only have 3 sig figs, right? Divided by, what's my denominator? 0.063, or my denominator is 0.0630 kilograms, 3 sig figs. So this is equal to 1.015 divided by 0.063, 16.1 molar. Okay. Mole per kilogram. So the molality is 16.1, 3 sig figs. All right. Now, you remember last time we said concentrated HCl is 12 molar, it's 12 moles per liter. So the molarity of concentrated HCl is 12, the molality is 16. Okay? So it's mole solute per kilogram of solvent. So can you do parts per million? That should be easy, right? How do you do parts per million? Mass HCl over mass total times what? A million. Instead of times 100 to get the percent, you get times a million, right? So ppm, I'm sorry, would be 37 grams HCl, okay, over how many grams total? 100 grams total. Okay. Times 10 to the 6th. Okay. That will give you ppm. Okay. 10 to the 6th. How do you get mole fractions? Mole fraction of HCl would be moles HCl over moles total, right? So moles total is moles HCl plus moles water. Again, how do you solve for moles HCl? 37.0 grams HCl. How many moles? What's the molar mass? 1 mole of HCl is 36.46 grams. Okay. So again, this is 37.0 over 36.46. How many moles of water do we have? The water is 63 grams. So 63.0 divided by 18.02. Okay. That would be your mole fraction of HCl. So converting within the same type of concentration units should be pretty straightforward. You just need to be based on the known concentration. So what's the strategy? Based on the known concentration, assume any amount for either the solute, the solvent, or the solution. Okay, and then figure out all the others. And then you have enough information to calculate any type of concentration unit you want. All right. Here's another example. Let's say you have a mixture of benzene C6H6 and toluene C6H5CH3, and the mole fraction is 0.25. What's the mole fraction of toluene? Percent by weight toluene, percent by weight benzene, molality, parts per million, and parts per billion. What would you have to do here? You're given the mole fraction of benzene. Mole fraction of benzene. Let's just call that X sub B is 0.25. What's the mole fraction of toluene? 0.75. What would be a good number to assume that you have here? You can assume you have what? 1 mole total, right? If you have 1 mole total, then how many moles of benzene would you have? 0.25 moles of benzene, right? And how many moles of toluene would you have? 0.75. Can you convert moles to grams? So moles benzene can be converted to grams benzene. Moles toluene can be converted to grams toluene. So if you know grams of benzene and toluene, how are you going to calculate percent by weight? Toluene. It's just however many grams of toluene you have divided by the total grams, right? Times 100% would give you your percent by weight toluene. How do you get percent by weight benzene? However many grams of benzene you have divided by the total grams, that times 100% would give you your benzene. Okay. And then molality. What would be considered your solvent here? You consider toluene as your solvent, okay? And then so you can say moles benzene divided by kilograms of toluene. Do you have moles of benzene? You do, right? Right here. Do you have kilograms of toluene? You can convert your grams to kilograms. Okay. Oh, by the way, I think going back earlier, the unit here is ppm. Okay, parts per million. The grams will just cancel out. to get ppb, parts per billion, it's multiplied by 10 to the 9th ppb. So this is really like multiplying by 100%. When you multiply by 100%, you're multiplying by 100 parts per 100. 100 parts per 100 is 1. You're multiplying by 1, basically. Okay? I'm not really comfortable with the way these things are done because, you know, grams, HCl, grams total, all the grams and grams cancel out. You're really canceling two different grams. So if you're really very picky about units, the best way to do this is to really just say grams of what per gram of what. Okay? So instead of saying, okay, let's look at this number right here. Let's go back to this. What is this? 37 over 100 times 10 to the 6. What would that be? 37.0 times 10 to the 4th parts per million, right? Okay. So you say that would be 3.70 times 10 to the 5th parts per million. I'd much rather say this is 3.7 times 10 to the 5th grams HCl, okay? Milligrams of HCl per kilogram of solution. Because that's what part per million really is. Okay, how does that unit come about anyway? You say it's 3.7 times 10 to the 5th grams HCl over grams of solution, right? I'm sorry. No, it's 37 grams. 37 divided by 100 is how much? 0.37, right? This is 0.37. Correct? So it's really, okay, so let's see where that comes from. You can say it's 0.37, 0.37 grams HCl per grams of solution. And then you convert your grams to milligrams. So 1 milligram HCl is 10 to the negative 3 grams of HCl. Okay. Grams will cancel out. So you now have milligrams of HCl. And then convert grams of solution to kilograms of solution. So you have 10 to the 3rd grams of solution is 1 kilogram of solution, right? So grams of solution will cancel out. So your unit is milligrams of solute, milligrams of HCl per kilogram of solution. Okay, and essentially what happens here, this is just 10 to the 6th, right? 10 to the 3rd divided by 10 to the negative 3rd, that's 10 to the 6th. Okay, so we have 0.37 times 10 to the 6th, which is 3.7 times 10 to the 5th. Okay, what if you're going to convert from one type of concentration into another? Okay, same strategy, basically the same strategy, but you're going to need one additional piece of information, and that's density. So whatever that quantity is that you know in terms of volume, okay, you can change that to mass using the density. What's the relationship between volume and mass? Density is mass over volume, right? So if you have a type 1 concentration, assume a volume of any volume of the solution. That's a good strategy to use. Then use the density to calculate the mass of the solution. If you're using if you know the type 2 concentration, then assume any value for the amount of solvent or solution, okay? Assume a value for the mass or moles of solution or solvent, then figure out the mass of the solution. And once you know the mass of your solution, you use the density to change that to volume of solution. And then you can figure out all the amounts you need to calculate whatever concentration unit you're interested in. Let's illustrate that with conversion from molarity, from percent by weight to molarity, okay? If you have a concentrated hydrochloric acid solution, it's 37% by weight HCl in water. The density is 1.2 grams per mil. So what are we going to assume here? I know percent by mass, so what's a good assumption to make? Okay, so 100 grams of solution, right? If I have 100 grams of solution, can I figure out the volume of solution? Density is mass over volume, right? How do I solve for volume? Mass over density, right? What's the mass of my solution? 100 grams of solution divided by density of my solution is 1.20 grams per ml. Okay. So what's the volume of my solution? 100 divided by 1.20. 83.33. So it's 83.33 milliliters. Keeping in mind, I only have 3 sig figs here, since 1.20 only has 3 sig figs. So that's 8.333 times. Okay, I'm just gonna keep that like that. I can say it's 83.33 milli means 10 to the negative third, right? So times 10 to the negative third liters. So I know my volume. What other information do I need to calculate molarity? Moles of solid, right? Do I know moles of HCl? If I have 100 grams of solution, how much of that is HCl? That gives me 37.0 grams of HCl. Can I change grams to moles? Yeah. So let's calculate our molarity here. Molarity is moles of HCl over volume of solution, right? And what's our moles of HCl? 37.0 grams HCl times 1 mole of HCl. What's the molar mass? You remember? 36.46 grams. Okay. So grams HCl cancels out. Okay. What's my volume of solution? We already figured it out. It was 83.33 times 10 to the negative third liters. So that gives me 37 divided by 36.46. 1.015. We did this calculation earlier, huh? Moles, 3 sig figs, divided by 83.3 times 10 to the negative 3 liters. Divided by 83.33 times 10 to the negative third. That gives me 12.2 moles per liter. Okay. Remember we said concentrated HCl is 12 molar. It's 16 molar, it's 12 molar. Okay. So that's how you convert from one concentration unit to another. How about this one? This time you're given the molarity. How do you change it to molality? What would be a good amount to assume? What's the definition of molarity? Mole solute per liter of solution. So a good amount to assume would be a liter of solution, right? So assume you have 1 liter. So volume of solution is 1 liter. Can I calculate the mass of the solution? Mass over volume is density. How do I get the mass of solution? Density times volume, right? What's my density? 1.22 grams per mil. What's my volume? No, my volume. As we're assuming you have a liter, so that's 1,000 mils, right? A liter is 1,000 mils. So what's my mass then? 1.22 times 10 to the third grams, right? Correct? Okay. Or that is how many kilograms? 1.22 kilograms. Why am I interested in doing it in kilograms? Because the definition of molality is kilograms of solvent, right? But this is kilograms of solution. Okay, so you don't use this, you can't use it directly, you still have to figure out how much solvent you have. So, what's the mass of my solvent? First of all, let's do the solute first. How many moles of solute do we have? If you have 1 liter and it's 5.08 molar sodium hydroxide, how many moles of sodium hydroxide do you have? 5.08. Okay. Now, how do I figure out the kilograms of solvent? I have to subtract the mass of the solute from the total mass of the solution to get the mass of the solvent. Right? So mass of solute, mass of NaOH would be equal to what? 5.08 moles NaOH, change that to grams. 1 mole of NaOH weighs how much? 40.00 grams per mole. So moles cancel out. That gives you how much? 5.08 times 40, 203.2 grams. NaOH. How many kilograms is that? And sig fig wise, that's only 3 sig figs, right? So that's 0.2032 kilograms of NaOH, with the last sig fig being this 3 right here. So do I have information to get mass of solvent now? Total mass of solution minus the mass of solute will give me the mass of my solvent. So kilograms of solvent, my water, would be equal to 1.22 kilograms minus 0.2032 kilograms. Okay? 1.22 kilograms total minus the solute. So this is total, and this is just the sodium hydroxide part, and that gives you mass of solvent. So what would that be? .22 minus 0.2032, 1.0168. Okay, I should stop at the second decimal place, so it's really 1.02. Okay, 1.017 kilograms. I'll keep an extra digit there, but I know that this one right here is my last sig fig. So now, how do I get molality? Molality is Definition of molality, moles, solid, so 5.08 moles of sodium hydroxide. How many kilograms of solvent do I have? 1.017 kilograms of solvent. So that gives me 5.08 divided by 1.017, 4.995, rounded up to 3 sig figs. That's going to be 5.00 moles per kilogram. So the molality of my sodium hydroxide is 5 molal. Okay, so let me say this solution is 5 molal. 5 moles of sodium hydroxide per kilograms of salt. Okay. Now, when you're dealing with very dilute solutions, a few things you need to be aware of, which would be really helpful, is that molarity and molality are almost the same if you're dealing with very dilute aqueous solution. Why is that? Well, remember that 1 gram of water has a volume of 1 milliliter, right? The density of water is 1 gram per mil, or 1 kilogram per liter, 1,000 grams for 1,000 mils. So if you have a small amount of solute, okay, remember if you have very dilute solutions, you have a very small amount of solute compared to the amount of water, so it will hardly affect the density of the water. So in very dilute solutions, we say then that 1 liter of solution will essentially be 1 kilogram, right? Will weigh 1 kilogram. And that will be pretty much 1 liter of solvent and 1 kilogram of solvent. We're saying that if you're dealing with very dilute solutions, the total mass and the total volume is essentially that of the solvent. So you don't care whether you're dealing with solvent or solution. And so your molality, so moles per kilogram of solvent will be the same as moles per liter of solution. So if I have like 0.01 molar solution, chances are it's also 0.01 molar, provided my solvent is water, okay? Because it's important there that the 1 kilogram of solution is essentially 1 liter of solution. So when we're dealing with very dilute solutions, molarity and molality are almost the same. But you can see, you've seen that with the HCl. When you have concentrated solution, 12 molar HCl is actually 16 molar. They're not the same. But once you get to very dilute solutions, the molarity and molality are essentially the same. And ppm and ppb, okay, would be essentially the same again, because a kilogram of solution total would be essentially be 1 liter of solution. So ppm and ppb, parts per million and parts per billion, would also be essentially the same. They're not the same. What I meant to say is milligrams of solute per kilogram of solution would be essentially the same as milligrams of solute per liter of solution. Okay? So milligrams per kilogram will essentially be the same as milligrams per liter. So that's why sometimes you see ppm shown as milligrams per liter. Because typically when you use ppm, you're dealing with very dilute solutions. Same thing with ppb. Okay, so just a quick check on that idea. For which of the following is the molality of HCl essentially equal to the molarity? Everyone's clicked in. So what's the correct answer? Very good. Ah, no. Oh yeah, I'm sorry. It's B. I thought you all picked A. All right. So in fact, we did show earlier that this was 16 molal, right? But you would expect, since this is very dilute, this is going to be approximately also 0.1 molal. So little m is molality, big M is molarity. Okay? Which of the following, for which of the following is the concentration is essentially equal to 5 milligrams per liter? 5 ppm benzene in water, or is it 5 ppm benzene in ethyl alcohol? The density of ethyl alcohol is 0.79 grams per ml. Let's see if you remember. For which of the following is the concentration is essentially equal to 5 milligrams per liter of solution? Okay, let's see. Correct answer is A. Very good. Why? Because we say then that since this is very dilute solution, 1 liter of aqueous solution is essentially 1 kilogram of aqueous solution. Okay? So, but ethyl alcohol, an alcoholic solution, since the density is only 0.79 grams per ml, you say 1 liter of alcoholic solution, in this particular case, is 0.79 kilograms. So you cannot say that the parts per million there is going to be the same. Okay.